Hey everybody, welcome back to Geometry. This is Mr. O'Shea, and today we're going to be talking about section 1.3. And in 1.3 we're going to be talking all about segments, rays, parallel lines, and planes. So we've got 4 topics to cover. I'm going to try to knock this out in less than 20 minutes. Segments, rays, parallel lines, and planes. Now the first one we're going to talk about is a segment. And what a segment is, it's basically the part of a line consisting of two endpoints. So it's basically a line that has two exact endpoints, two very specific endpoints. And it also includes all of the points in between those two endpoints. Now what you guys really have to focus on is this idea of endpoints. So we've got a specific start and a specific end. These are different than lines, which would go on forever. If we're talking about a segment, we're only talking about, not those pieces that extend, we're just talking about that middle section with the two specific endpoints. Alright, the next thing we're going to get into is a ray. Now a ray, similar to a segment, it's a part of a line, but this time it consists of one endpoint. So a segment had two specific endpoints, a ray only has one specific endpoint. Now if it only has one endpoint, that means that the other side is going to extend in the opposite direction indefinitely. So again, it has one specific endpoint and the other side of it extends in the opposite direction indefinitely. Actually, I don't know if that's how you spell indefinitely. I'm going to go with it. So there's my endpoint. It's a nice little green marking here. And I can extend actually in any direction. Let's make it go off to the right. And that arrow on the end means that it's going to go forever. Now if this were truly a line, it would go in both sections, but it doesn't because it has that one specific endpoint. Now we're going to get to this idea of opposite rays. And what opposite rays are, they're two collinear. Now remember we talked about collinear. Collinear means, from last lesson, the same line. So what opposite rays are, they are two collinear rays, so rays on the same line. Now these collinear rays, they have the same endpoint. You might be saying, hey, how does that work? Well, we've got one endpoint. We're going to extend it forever in one direction. Make it go off to the right there. And another ray that's on the same line, but it's got to go in the opposite direction. So two collinear rays with the same endpoint. You can basically think of it as this big straight line. Two rays that go in opposite directions. Alright, example 1. We've got that line there, L, P, and Q, and I want to name all the segments. So I'm going to go ahead and see all the segments here. There's one segment there with two specific endpoints. It starts at L and it ends at P. And I've got another one. We can call it starting at L and going to Q. So that's going to be L, Q. Now if you guys notice the little line that I put over it, I didn't put arrows on top of those lines. It's just a very specific endpoint that indicates a segment. So I've also got PQ with just a line over the top, no arrows, because it has two endpoints. Now you guys could also name that one QP. You could go backwards. And that one there could be QL instead of LQ. And obviously the yellow one then would be PL instead of LP. They all mean the same thing. It's perfectly fine. But again, the symbols on top mean that they have a start point and an end point. And if we're talking about LQ, we're talking about all the points in between. If we're talking about LP, we're talking about all the points in between. So let's talk about rays. Rays have a very specific endpoint and then they extend indefinitely. Now these do matter how you name them. So we're going to start with our endpoint, L, and it extends past P and forever and ever and ever. Now you could also name it LQ. Again, it starts at L and it extends to Q forever and ever and ever. Either one is the same thing. Now you can't name it PQ, you can't name it QL, you have to start with the L because the L is our actual endpoint. Alright, so let's clean those up a little bit. We could also start at P and go to the right. That would be ray PQ, where we start with P and we extend to Q forever. We cannot call it QP, even if you put it backwards. We're not going to write it like that. We always start with the endpoint first and extend the opposite way. So you'll never see it actually written backwards with the ray written backwards like that. Alright, we've got a couple other ones here. We could start at Q and go forever the other way. And that could be ray QL, or we could call it QP, doesn't really matter, so long as Q is our endpoint. And we've got one last one in there. Let's go ahead and start that at P and extend it to the left. That's going to be ray PL, starting at P, extending towards L forever and ever and ever. And now we're going to talk about parallel lines. Now, you guys should probably have some idea what parallel lines are from previous classes, but we're going to make it a little bit more mathematical in our talk because we're going to be talking about coplanar lines. Remember, coplanar, lines that are on the same plane. And these are going to be coplanar lines that do not intersect. They never, ever, ever intersect each other, but they have to be on the same plane. Now, you might not always see the plane, but they're going to be on some type of a plane. Now I also want to talk about a symbol that we're going to use. So if we've got this line AB, and we've got another line, well, let's make that actually parallel. Let's get rid of that bottom line there, and make it so it actually looks like it goes in the exact same direction. Be a little careful. Alright, so we've got AB and line, let's call this one CD. And those go on forever and ever and ever and never intersect. We're going to say that line AB with the little symbol above it. And you guys see these two dashes, two lines. They look like two L's. That's going to be the symbol for parallel lines. So all we wrote out right there was that line AB is parallel to line CD. That green marking meaning the parallel ones. We've got another type of lines, and these are going to be skew lines. Now what skew lines are is they are non-coplanar, which means they are not on the same plane. Anytime you have non-coplanar lines that also never intersect, we're going to call those skew. Now that might be a little tricky, so we're actually going to look at a kind of a visual. See this blue line right here? And if we take this blue line up top, they are not on the same plane. They're on two totally different planes. But if you extend them forever, they're never going to intersect each other. Another example would be this purple one back here. And this purple one up front. If you extended those forever, they're never actually going to cross each other. So if you were actually like holding a box and you ran your hands along the side, you'd actually be able to really easily tell that they never ever touch each other. And they're on different planes, so they are skew lines. Alright, parallel planes. Now parallel planes are very similar to parallel lines, except for the fact that these time they're planes that never intersect. Instead of being lines that never intersect, they're planes that never intersect. Visual of this would be maybe this left-hand side, the one that I'm tracing out in yellow, that plane, and the plane on the right-hand side. If we extend those in every direction, so off to the left, off to the right, top and bottom, and then we took that other yellow one and stretched that in every single direction, those two things would never touch each other. So we consider those parallel planes. Another example might be the top of the shape and the bottom of the shape. Again, if we extend those, sorry about that. We extend those, they're parallel, they'll never touch each other. Let's go with one more here. Maybe the front of the box and the back of the box. You can't really tell that that's the back. but the front of it and the back of it, again, parallel, never intersect. All right, we've got a handful of items on this next one here. I want to know what are the segments that are parallel to line AB. So I'm going to look at AB, it's right there. Now the only one that's actually parallel to it, it's on the same plane, it's going to be FG. It's the only line that is actually parallel to them. All right, we've got JE, or I'm sorry, EJ. And I know that EJ is going to be skew to, there's a whole bunch of different ones we could use for this. Ooh, that was a little off. It could be skewed to LH, different plane, different direction. It could be skewed to, we could use FG, different plane, different direction. Now these are just a couple of examples. You guys could have a lot more. We could use CD on there. Oops. C to D, there we go. CD. You could use AB, you could use GD, BH. You could use a ton of different ones so long as they're on different planes and they never intersect. All right, let's clean this up just a little bit here. Got a little more writing to do. Oop, there goes my J. Got to rewrite that one. Now, if you guys are doing this at home on your paper, I would suggest maybe doing these in different colors, or use pencil and then erase it as you go. Might be a little easier for you. All right, I want to know the ones that are parallel, what lines are parallel to plane JFAE. So we're talking about J, F, A, and E. That is this front plane right there. I want to know all the lines that are parallel to it. Well, none of those planes look like they go in the exact same direction, so none of those are going to be it. So actually, when we're talking about the lines, it's actually just going to be the lines that are on that plane. We got JF, or we could use JE. We could even use EA. And the last one we could use is FA. Those are the only ones that actually go in the exact same direction as that plane. And now we've got one more. I want to know, where's the intersection? Intersection means where does two things meet? Where's the intersection of plane FAB and plane FAE? All right, I've got FAB, so that is actually that plane right there in blue. And FAE, FAE. So that's that one that we have highlighted there in red. What is the intersection of those two planes? Where do they meet? Well, they meet right there. They cross each other, kind of intersect each other at line FA. Remember we talked about that yesterday. We talked about the fact that when we're dealing with these, we have two planes that intersect. They're always going to intersect at a specific line. Okay. All right. Moving forward, we've got another little example here, and I want to know, is CB parallel? We're using the parallel symbol. Is that parallel to HG? Well, yes, they are. They're on the same plane. They go in the same direction, never intersect. All right, we're going to look at ED. ED is down there on the bottom. And HG. Well, ED and HG, there is no plane that those two share. They'll never intersect, but they're not on the same plane. They're non-coplanar, so those are actually not parallel. All right, 3 letters. So we know we're talking about a plane. AED. So that is that front plane. Is that front plane parallel to FGH? Those 3 points lie on the back plane. Is the front plane parallel to the back one? Yes. There, that one's true. We've got A, B, H. That's that kind of slanted one on the back, the one we're highlighting in white. And then we've got C, D, F, which is that front one. Are those 2 planes parallel? No, they're not. If we extend it,
They'd probably hit somewhere pretty high, but they would definitely hit. All right, let's go ahead and clear this up a little bit here. That one was, we said, true. The next one was false. And that brings us to the yellow one. Line AB. Is line AB and line HG, are those skew lines? Remember, skew lines are non-coplanar and they never intersect. Those two are not on the same plane. And if you extend them, they never will intersect each other, so that is true. And the last one, CG and AI. Are those skew? See, now this is a tricky one. Because you might think that, hang on, these two are not on the same plane. Now, here's the piece that it's a little weird, right? They're not on a visible plane, but they are on kind of this invisible imaginary plane that runs through the middle of them. So the fact that we can extend this invisible plane, see how we got that one in the middle there? Now all of a sudden AI and CG are on the same plane, so they're actually parallel lines, not skew lines. All right, that's all, everybody. Try the check yourself problems located at the end, and I'll see you in class tomorrow.